Hello there. It's Alex from Blue Lightning Software. Just streaming again. This is more jobs system. My first attempt at the job system is quite a hefty fumble into it. About an hour yesterday, hour and a half. Just looking at the differences between tasks and jobs. One thing that became apparent is that, all right, here with the take-homes, I think, jobs and tasks kind of similar, all right, I think, in terms of overhead and execution time. The tasks and jobs are both just scheduling threads in essence, yeah. New threads in the way that we were using them, tasks particularly. Burst made jobs run 10 times quicker. That was the take home. Burst compile, literally just the you have to structure a struct for a job like this, but the burst compile alone, that's kind of like almost 10 times as fast in certain mathematical operations. This kind of stuff, it seemed to be about 10 times quicker ish. I mean, that's an estimate, 5 to 10 times, something like that. It was a huge step. Burst compile definitely made it much quicker. You have to stick to the format of ins and outs and have this execute. That was about it. That was the job. And then the job was scheduled and it ran. Job handle. Right, the difficulty was jobs have to complete. Okay, now the job has to complete, or for you to move on and take the result of the job somewhere, it has to be completed. Now let's have a look. There's a few ways to do that. Jobs finished is what I'm looking for. Jobs finished. This complete all. This actually, for a big stack of jobs like this, where we job handles. Now this makes sense now. The job handles is a native array. Everything that Unity passes between its native C++ kind of under the hood Unity layer, native code of Unity, where it's running much quicker than the C# layer that we create usually. The native array communicates between that layer and the C# layer. It's this native array exposes a buffer of native memory to manage code, making it possible to share between managed and native without marshalling costs. That's interesting. So this is a very quick way of sharing the data between the two. Okay, so it gives a very quick layer of communication between that managed code and the native layer of Unity. So having this native array of job handles, when we create all the jobs, we stash them into there. The job method, this job handles native array of job handles is created. We then stuff that array with all the job handles. I guess it's probably not quicker, but you can just do that, yeah. You don't need that pointer or whatever reference job handle. That is a job handle. The job. What is returned from job schedule? You schedule the job. It returns a job handle that we stash into this native array. Now, what's quick about this, right? This potentially is the quickest method. When you get to jobs finished, after all of them have been scheduled, this complete all from job handle, a job handle static method complete all, we give it job handles. I wonder what the overloads are there. Hold on, what's the other ones? Jobs like that. List of jobs. All right, so we're giving it a native array of the job handles. Now, because it's a native array, this is so quick. This is probably one of the reasons this is so quick. Actually, this, I think, is the quickest way possible to say, is a stack of jobs in a native array of job handles, is it all completed? And that does them all at once, probably on the native layer, checking if they're all finished, and comes back and says yes. But all of these completion, there's an element of the scheduling and an element of the complete of job completion, and job scheduling is locking the main thread. So when it does this, I'm not sure what I've rigged it because I was messing about. So let's just check. Job method, blah blah blah. Task test, jobs test. Here we go. Schedule. Job finished. Job finished. All right, because I started stuffing stuff into this, which I'll show you later. But this is going to jobs finished, and it's scheduling all those jobs, and kind of in the same statement, it's saying complete all. You'd worry that this would block this. There's arguments that, like, all right, you create a job, you complete the job, all right. This was some arguments about the speed of job completion. It is on instant compile, actually. That was. So let's just look at the results anyway. So these are tasks. This is how long tasks are taking to do this. What tasks don't do, if you've rigged them properly into an async and it's different threading, the task, right, I mean, the jobs are lightning fast, run like that with this information, and it's the same whichever way you take it. Jobs are massively fast with burst compile in this structure. It's certainly one of the ideas. When you start pressing complete, though, right? Say I scheduled a job. Let's have a look. Job method. Job method. Suppose we did this. Job schedule. All right, we'll even load that native array because it doesn't matter. All right. Does it? Job schedule dot complete. You can almost write that. That looks so dumb. Yeah. What's going on if we did that instead? Okay, and then the task finished. Jobs finished. Did practically nothing. Yeah. It just timed it. This is some nonsense to do with something else that I'll show you later. So what's happened here? We could do that in two separate statements. We could store the job handle and complete it. Whatever that is, that job handle of the schedule, return from schedule being completed. Asking it to wait until completion. All these complete statements are saying hold until done. They're like wait until completed. Okay, let's see the time on this. 48 and 77. That was with settings that are in this at the moment. The current test settings. So let's have a look. So 44 and 77. Yeah, look at that. The difference. Can you see the difference? What that does, complete like this, it forces the main thread to complete it itself possibly. There's some weird logic behind what's going on with job scheduling. So you schedule it. That ships it out to the queue. There's like a queue behind it. I should have got a diagram out. There's a queue in the native. I think it's inside the native layer of you call schedule. It communicates with the job system, where a queue waits to allocate to a worker thread. Now, I'm not sure if I've got it open. There's all stuff like the way this works in Unity. Okay, it has to wake a worker thread. It has to assign the job to that worker thread and run it. Okay, and then it comes back. Now, before it does that, if you immediately say complete, okay, complete is blocking the main thread. Okay, so it says in this circumstance, some reason it says, I just use the main thread. I think that's the case. If the job has been scheduled and immediately asked to complete, it wouldn't be so obvious if you said like job handle equals. If you wrote that, okay, that's kind of what we did right anyway. There's no time here for the queue to wake up a worker thread, assign the job, and then run it. Okay, so what complete says is, I think this is right theory. Okay, there's some diagrams what could be happening. It's not actually 100% at all. It depends on the job system state at the time, how many jobs it has, what's going on. But it's quite possible. Complete will whatever lock up the main thread while it waits for it. It could actually assign the job to the main thread to complete it, given that scenario. Okay, so it's just doing it like that. You might as well run it on the main thread. All right. If you did job schedule complete like this, the chances are it's just using the main thread. So we could see the result is slower than task, way slower, and it's just locked up. And that's just like using the main thread. Whereas scheduling here, we're giving it time because actually this whirring around, all the scheduling and stuff, it's definitely independent of the main thread in terms of as this is scheduled, this has gone out, the job system is doing its own thing, definitely. Just from the workings of this example, I would say, I mean, the exact what is going on behind the scenes. Yeah, you could look at the diagrams and try to work it out, and they hopefully it's pretty static and they don't change it much. This was an interesting one, right? This line, job handle, schedule, batch jobs. This kind of forces them into this pushes them out of the queue into threads. All right, it's I'm not 100% about that either. It doesn't seem to make a lot of difference in our example. If I went to jobs finished again and just set it back to how it was. I think we're all back there, yeah. But remove the schedule batch jobs that was in there from testing. I don't think it makes any difference in this setup. But you can see the huge difference between that immediate complete on the job handle and triggering them all off. So what it's doing is by the time it's sent them all out, they've had time to do the work. All right, so I might be overdoing that because it could be to do with a little bit of how job handle complete all works. Yeah, that may function slightly different to just straight up complete on the job. Yeah, this is supposedly the quickest way to end all or a bunch of jobs in a native array. So just catch your breath. Well, I tend to re-import these twice sometimes. Let's look at this. Hopefully this is 44 and 77 milliseconds again. Yeah, ballpark, yeah. I don't think batch thing is doing us a lot of difference there. Oh, where's the other call from? Oh no, this is a different thing that I can show you later. So this kind of enforced by running it like this, because just the 58 milliseconds is triggering all the schedules. Okay, so we're in the code. The job test, it triggered them all here. It took that 58 milliseconds time. It then went to finish the jobs. There's then 77 milliseconds all done. By that time, they'd actually been queued out into threads and mostly done. 49 milliseconds was enough time to trigger it all, to get them queued out and into threads and run. Okay. Whereas doing that kind of thing, or just straight into complete without the handle, that does not give it enough time to queue out into threads at all. That looked like it was just stuck it onto the main thread, because that call to complete is blocking and just using the main thread to run the job anyway, possibly. Or it will block the main thread until that complete comes back, which itself takes a bit of time. So I'm finding this really useful. You're not going to beat this, putting them all in a native array and then complete all. If your desire in the code is to say that they are all completed before I move on, wait for them all to complete here. Now this is trouble. We're back here. What if there was a crazy workload? Okay, 100,000. These don't actually make a huge amount of difference, because it's 10 times the work made it 10 times longer. Yes, it does make a difference. All right. What if I did 10 times as many jobs doing that larger number of work? So is this going to be 7 seconds now? Let's wait. Notice it is just locked. All right. The box is now locked for 7 seconds. Yeah, literally locked. Complete all has frozen your main thread. All right, despite being the quickest way to do this, you are frozen for 7 seconds. Now that's a game. If you think of a game, it's not frames, that's seconds. That's seconds locked. All right. Reduce the workload back down. You are still blocked for 0.7 seconds. You're down to less than 2 frames per second because of that block. This you might not notice, but that's quite a bit of time. That's a 60 millisecond. Think about 100 frames per second being 10 milliseconds each. That's just slowed you down, right down. This amount of work has taken you down to, you are locked by the job system for that amount of time. The completion command and even just the scheduling is locking up. With this number of jobs, you're locked. The task isn't locked. All right, so let's go back to the huge number of work. All right, the difficulty is task can't actually do this amount of work. It's taking ages, but it's not actually locked while it's doing it. Can you see that? I don't want to press this jobs button, but look, I can highlight those and change them while the tasks are running. It's still running, is it? I might have driven it insane by changing these numbers and pressing tasks too many times. But it was not locked. The main thread was not locked. i.e. technically you could do these in the background using tasks without a complete statement. Locking your main thread, the tasks could take ages to do it. Let's get the comparable jobs time. And the jobs, you could trigger them asynchronously, because there we go, that's the difference in time. But the jobs time, that was locked. The tasks were not locked. Yeah, for 10 times longer, but without locking. That's a benefit of task for extremely. I don't see where you'd ever use this, but I mean, obviously that's where tasks are. Jobs can't run those file load things that take forever, or downloads or whatever that tasks would often be used for. We've had some huge amount of math going on. It had to calculate the weirdest, longest mathematical calculation that I can't think where you'd use it. But if you did, the task would be easier not to lock your box. The other way of doing it, suppose you just didn't complete all. If that was never called, I'm just interested to see. You just triggered all those jobs and forgot about them. Just to see how that affects the timing. I mean, is the scheduling the same? It's 44 milliseconds. About the same numbers. It's weird, actually, if anything, it sped up the first number. Just by having a finish on it. It's bizarre. But, yeah. That's interesting. Then I started looking at what if in the update, what you're supposed to do, you farm it out to the update. I read out this. It's not the best algorithm. Just having a boolean, just counting through all of the job handles. So we filled up the array with job handles. The other thing you can do with the job handle is completed. You can say, is it completed? Yeah, break. Come back to it. So it's not saying complete, wait till completed, it's saying just, is it completed? And what this would do, the first one it comes to, it would break out of this while loop, set that to jobs done. If jobs done is all of them, jobs finished. Okay. It's massively hard. It's just a bit quicker than looping all of them each time. It kind of sets the number it got up to, where they're all complete up to I. Set that. So the next update frame, it comes around, it starts on that number. Yeah. And it goes through them again and says, is it when it's completed? Break when it's not. Set that number. If it's that, it's finished. Yeah. Jobs done equals -1. If jobs done is return, don't bother doing all this. Yeah, that just is looking at them, is completed, each one. So I was hoping would be completely non-blocking, but it's not. So we take out that. So now what it's doing is loading these all up as before into our native array, and then it's going through that native array. I mean, technically this one doesn't have to be a native array. I don't know if that slows it down. I doubt it. It might be marginally slower than a normal array, I'm not sure. But anyway, for this purpose, I mean, if you really had this amount of work going on, you need to start. There are batchable functions, you can run parallels, all this kind of stuff, but you're going to have to rig up systems that load jobs. You're dealing with the job system so that you don't overload the job system each frame, thus reducing your frame rate. Look, this is slow now. Does it even work? It did work. It's blown up. Didn't even work. Job method, job test. Yeah, you have to set this. It's taking from -1 to 0. You have to set jobs done after you start it. So it'll all be whirring away in the background. The jobs, and in the update method it will test if they're completed and then eventually call jobs finished. Can you see how much slower that is? Those two numbers would be identical. And this gets bad because of the loop. It might be that array looping that array, but if you increase the repeats on this, it gets bizarre. I'd reduce the work, alright, because this can get slow. Can you see a lot of the work is now not the complexity? That's more the time of. That's not one massive 600 millisecond frame, because it only took 32 milliseconds to schedule those jobs. But if I put another 0 on this, that array may take forever. Yeah, and it's also totally locked. See, that's an interesting thing to watch out for. That it is locked worse than before, probably to do with this array and rubbish algorithm or something. I tried it with a very simple algorithm. Maybe there's a magic algorithm somewhere to do this, but this is completed itself, blocks the main thread. Okay, and the more calls you have, like 100,000, it could just be iterating that array takes forever, but it's not. You could see it in the 10,000. It's the call to is completed, and if you look around the forums, it is completed. Just checking it is completed is itself a blocking. It's probably because this has to ask the native system what's going on. Yeah, and it has to find that job and come back and tell it. And this blocks the main thread while it does that. It's not quite as bad as, wow, if I hadn't blown it up. Can you see the time? 57 seconds with 100,000. I mean, the other one would just be to iterate them all here. Job handles blah dot complete, which is just like the blocking wait until it's completed. Whoops, what a deliberate error. Okay, so let's have a look at that. There's also, someone says to make sure these are completed, jobs finished should always have this, right? And that would make very little difference given the circumstance. That would add no time at all if I put that back in. I think for dependencies and stuff, that now I've put complete, you're okay, but just the is completed, did not technically close them, perhaps. It's another little thing there. I'm going to have to come back to this. Hold on. Oh, sorry for the date. I don't think I actually did anything, is it? That's actually completely locked still. That is still completely locked. I'll have to use Task Manager at this point to end it. I'm not sure what's up with that task. This, given that amount of work, completely killed it. Maybe because it's doing it again and again every frame. Maybe I should have, given that method. Okay. Can you hear the dog snoring in the background? I don't know if it would pick that up. Yeah, so anyway, I can see what went wrong there. We have to set jobs done. Jobs finished. We should have called jobs finished immediately after this, actually. Jobs finished would have done it, but also set this. Jobs finished sets it to -1. Yes. So it doesn't do it every update. Could be that. So let's see that. I'm going to experiment and begin with a smaller number of jobs. I don't think it would be, because that each time was just allowing everything else to run with is completed. Although it was much slower and still ultimately blocking. This is actually running not badly. No, it's about the same as is completed. Could you see that? That's a similar time to is completed. Whereas if this was straight to complete all, that is a zillion times faster. Yeah, just that complete all is just way quicker. Was that locking as well? It appears to be. Just the fact that the button's not. So this again could take 50 seconds. Let's do half as much. Let's do not that many. See, it's totally locked. That's still highlight shows you it's locked for 2 seconds. Yeah, I mean, again, this completely locks the main thread. Doing this complete, there's not really a way around it. Looking around, there's no job completion checking in any of these formats. Even just saying is completed is locking up your system. So with these jobs, the other way of looking at it was, man, we could have used a kind of count thing. We could have, I'm reusing variables and it's messy, all right. We could have said give it essentially you wind up with these timing ideas. It's so messy, Sketchpad way of doing this. Alright, so I'm saying give it 4 frames, and we're going to go to jobs finished, and we're going to use this complete method there. So we actually gave it more time than the original method. We waited for 4 frames update, and then we call job finished. Yeah, so we're giving the things 4 frames. The weirdest thing on earth is the output. So I'm going to try 3. Jobs temp. I mean, I have no idea how this is the exact timing. Something like 4 frames on a job temp that we have for an output. Some bizarre persistence of the array. Oh, we said it's persistent, did we? No, did we? No, not that one. Job method. We insist on an output, a temp job. It's like 4 frames or something. So I'm just confusing myself. I don't think it matters at all. Anyway, so this is, if it's more than 3 frames, kill the job. Well, not kill the job, complete the job. So for the entire job, this is the entire set of jobs. This is like, yeah, this is back nearer to the original timing. But I just want to know if this would... Yeah, I mean, you're still just locked up. But why is that even locked up? Because it's taking 4 frames is way within the 700 milliseconds. What you got to do, I think, is strategies. If you had this amount of work, there is the parallel 4. You can send in batch numbers, okay, but that's a slightly different concept. Yeah, if you had so much work going on, you'd almost have to avoid a real lockup. You'd have to have an idea of how long your work is going to take, subdivide it, create different native arrays, like these job handle arrays. You'd almost have to have a job system loading system, if that makes sense. To make sure you don't ever overload. Because the finishing time on these, I mean, none of it really makes sense. I mean, in terms of what I'm doing now, I could say wait that number of frames, that kind of thing. Because if the work is just done, this complete all is pretty quick. Yeah. It was just frame delay, and when the jobs were actually done, when it got here, these were all done. These were all finished jobs. That was quick. That's probably quite instantaneous, particularly doing it this way. all of them at once via the native array complete all. So yeah, but if the work is not done when it gets to this line, this is going to block it all. So you got to make sure that you believe the jobs are all finished by the time you get to here to prevent a lock. Therefore, you need to batch your jobs. Oh my God, listen to the dog. Interrupting the conclusion. Dog. Dog outside. That's triggered off. Anyway, yeah, so I mean, you have to schedule a number of jobs. Doll. Yeah, you'd have to schedule a number of jobs. You have to make sure that when you get to this line, you expect all of the jobs to be completed by this time, and you're just calling this to make sure they are. And given amounts of work, you don't want to overload that, or it will actually lock up. It's interesting, the task system without the burst may take 10 times longer, but it won't lock up, so it kind of eases that if you ever expected this situation to occur. But it's kind of like with the way Unity works and the way it's expecting only 4 frames maximum, you should never really load up jobs that will take longer than a frame or 2, if that makes sense. So it's just something to think about. That's kind of how it works. Sorry about the dog. And yeah,